In this video, I'm going to solve two work-related problems, and we will use rational equations to solve the problem. A work-related problem is an example of real-life situation that can be modeled and solved using rational equation. In work problems, sometimes there is a need to calculate how long it will take different people working at different speed to finish a task. Okay, so algebraic models of such situation often involve rational equations that derive from the work formula, and the work formula is W is equal R times T. Okay? So, let's try figure it out. Some work problems include multiple machines or people working on a project together for the same amount of time but at different rates. Okay? Therefore, you can add their individual work rates together to get the total work rate. So R is a work rate, T is the time that the job is going to be done in. So let's review an example. Myra takes 2 hours to plant 50 flower bulbs. Okay, I'm writing down Myra. 2 hours, 50 bulbs. Francis? Takes 3 hours to plant 45 bulbs. Oops. I was typing based on a dictation for Siri, and then bulb for Siri became bolt. That's pretty much a common case. Siri can do whatever wants sometimes. Okay. 45 bulbs. All right. So what else we have? Working together. The question is coming, I see. So together, it's going to be how long, meaning X hours, 450 bulbs. All right, so let's start figuring out. So if it's asking together how long it will take them to plant 150 bulbs, okay, that means we need to find out how long it takes them together to plant how many bulbs they can plant together within 1 hour, because our measurement is hour, right? So that's what it means. We need to know how many bulbs together they can plant within 1 hour first, and that after that we can find out how long it will take to plant 150 bulbs. So let's find out how many bulbs Myra will plant within 1 hour, Francis will plant within 1 hour, and adding together we will get together how many bulbs they can plant within 1 hour, right? Okay, so Myra, let me just write down here. Actually, I will make it more understandable. We'll do this. Okay, and together we put completely different color so we can work better. I'll take this. Okay, so this one didn't change the color. Okay, we are good. So if Myra for 2 hours planted 50 bulbs, that's mean for 1 hour it's gonna plant 25 bulbs, right? It's gonna be 50 divided by 2. 25 bulbs, right? Now, Francis, if for 3 hours planting 45 bulbs, for 1 hour, it's planting 45 divided by 3, 15 bulbs, right? So together, for 1 hour, they will plant 25 plus 15, 40. Yes? Okay, we know together they plant 40 bulbs. All right, now for 1 hour they plant 40 bulbs, how long it will take them to plant 150 bulbs? So we are making proportion. I'm going to show you how to make proportion. So we are dealing with the case when they work together. So 1 hour, 40 bulbs. X hours, 150 bulbs. So for the case of proportion, and I will place the video because I have special video for how to calculate the proportion. So we are going to do cross multiplication. 1 hour times 150 bulb. Let me do it this way. Multiply together, and 40 multiplied by X. So the result is, and keep it, pay attention, hours under hours, bulb under bulb. So we are getting 1 times 150 is equal 40 times X. All right, and from here we are going to get dividing by 40 both sides, and our X is gonna be equal, this is gone, and 150 divided by 40, we are getting, let me see, 0 and 0 gone, 15 divided by 4, it's gonna be 3. 3 times 4, 12, and 3/4 hours. So it takes 4 hours without 15 minutes. So 3 and 3/4 of hours, or 45 minutes. It should take 3 hours, 45 minutes for Myra and Francis to plant 150 bulb together. All right. Now let's solve the problem that is gonna be helping us to solve opposite direction, which is, let's say you can calculate how long it will take one person to do a job alone when you know how long it takes people working together to complete the job. All right, let's do it. Next question. Joe and John are planning to paint house together. John thinks that if he works alone, again this Siri, I checked it and it did slipped away from my vision. If he worked alone, it would take him 3 times as long as it would take Joe to paint the entire house. Okay, let's write down time. So time for Joe to complete the entire house is X. Time for John to complete the entire house, it's going to be 3x, right? Because it says John thinks if he would work alone, it would take him 3 times as long as it would take Joe to paint the entire house. So if Joe will paint for X the hours, then John would take for the paint for 3x hours. Or time measurement, I don't know what time they mean there. Oh, hours, okay, hours. So working together, they can complete the job in 24 hours. So time for together, 24 hours. Then let's here also type hours and hours. So in this case, we know that together it will take them 24. How long it will take each of them separate, individually to paint the house? How long would it take each of them alone to complete the job? So we need to find X and we need to find 3x, time for Joe and time for John. All right. So we don't know the square of house, the size of job they are doing. All we know is just the house. So all we know that it will take X hours for John to complete the work, and it will take 3x hours to complete for John to complete the job, and together 24 hours. So all around hours. We need to get out of circle of hours because we need the amount of job they need to complete. So because it's not given size of house or anything else, so here we are dealing with rate. So we are taking, in cases like that, total amount of job is 100%, which is portion-wise is going to be equal 1, right? Divided by 100, portion-wise, it's going to be 1. So, which means the rate of Joe, it's going to be, for X hours, Joe will complete 1 over X portion of job. See, it's a rate, because that's why I'm talking about portion of job. John would complete 1 over 3x portion of job, right? So, and for 24 hours, they will complete the full 100% of job. So, okay, let's now see how we are going to build our equation. So we are going to use the formula W is equal rate times multiplied by time. Since the time is given, it's 24 hours is together time, that means the rate also we need to use together. You can't take time for together work and multiply by the rate only for one or another. It doesn't work that way. Therefore, we are doing rate is going to be sum of rates, 1 over x plus 1 over 3x and multiplying this by time, which is going to be 24, and it's going to be equal work. Work is 100% of work, which is portion-wise, it's going to be 1. As you know, in operations, we don't manipulate with percentage, but we manipulate with portion. If somewhere you see percentage they are using, that means somewhere they divided by 100. You can't even doubt in that. So, from here, we are going to get, so let's multiply 24 over x plus 24 x over 3x, I'm sorry. This is supposed to be in denominator, and I was looking what's happening. Yeah. Okay, by 3x, and we are getting equal 1. All right, so let's bring to common denominator x and 3x. It's going to be 3x, which means here we are multiplying by 3. The second fraction, we don't touch it because we have 3x, and 1 multiply and divide by 3x. So since this is equation, we can throw out a window this denominator. And as a result, we are going to get 3 times 24, it's going to be 72 plus 24, and it's equal 3x, right? So 72 plus 24, it's going to be 96 is equal 3x. Since we are interested time for how much John will complete. So x is going to be 32. Okay. From here, it will take 32 hours for John. For Joe, I'm sorry. And 3x is equal 96. Let me rewrite. 3x is equal 96 hours. And that is going to be for John. It will take 96 hours for John to complete, to paint the house himself. Okay? All right. I'm done. Hopefully this was helpful, and I'll see you next time.